the microphone and everything? Cool. Okay, we can start. Well, sorry again for this latency. I was so sure that it was at 2 o'clock, and well, let's go anyway. So often so most talks. This talk is completely different from the talks I usually do when I talk about Playframework, because mostly it's about talking about Play itself and not talking about any particular scope or scenario. And now I'm like trying to see the problem from a completely different view, which is like what this track is about: data and big data and analysis and these kind of things. So at my company, we do these kind of apps. There are some we do these kind of apps, and we use Play for that. And I thought about sharing this experience about how we use these kind of tools. Basically, how can we not only analyze data, but then have all these and push them back to the client, because that also matters for an application. So I'm here with Earl Kasdadine. So I work at Zenexity as well as Earl. I'm the technology officer, the chief technology officer. I work with Earl on different projects, on different strategic projects. Most of them are I can't really talk about, but we'll try to get some context out of these projects. All right. So the first question I would like to ask, like where we are now, where are we now? Like what's happening right now? It's really exciting times to be in the software industry today, because a lot of things happening. We are hearing about like clouds, having different machines, computing different machines, getting back data. We're hearing about data. We're talking a lot about data, or data and bigger data, and even big data. And we're talking about functional programming. We're talking about infinite data, and all these things is really interesting. Like software development is becoming interesting now. It's not so before. What we had before in this kind of industry, I'm talking about enterprise industry and this kind of environment, we used to have this kind of object entity-oriented programming, let's say object-oriented programming. And mostly what people understand when we talk about this is having this entity that will be representing something that exists in the database. Mostly, well, all the time, relational database. And this entity is just this thing that has getters and setters for Java developers who knows about these. And by setting something here, it will set it back in the database. And it's kind of, that's it. You know, that's all what the programming was about. A lot of entities. Entities will be reflecting something in the database, and I will be like commanding the database through that entity. That's basically what people understand about object-oriented programming in this kind of industry. And it's like, it's enough to learn about Active Record or RM, Hibernate, whatever the tool you call, to start doing these kind of apps where you're just representing data from database. And that's kind of, first, it's boring. And it's, second thing, we're not doing any problem solving, right? We're not really doing the programming that we would like to do. And that's what we were doing. And suddenly, and that looked like something like this. Right, our little thingy, like we kind of manipulate things, and it lives or dies, and we can have few of it. That was the fact. That was software, programming and web programming in general. And now what happened is that we got a lot of data, and people started businesses started realizing wow, it's actually value is in data, and functionality is in data. Everything is in data. And let's look in data, and streams of data coming to me, and whoa, what can I do with that? Okay, I can use my tools I got, like this thing that I got, and I can start floating on top of this data and try to do something about it. But actually, it sinks. It doesn't work, right? It doesn't work because it's not the right tool for that. It's a completely different thing. Now we're talking about transformation data, and these tools didn't work. Well, hey, we can have several of these, right? Then I have the same tool and a lot of these kind of tools, and try to use that. And then I not only sing, but I think in my own tools, right? I get this complexity of these tools that are completely not fit to this, what I'm trying to solve, and I get this kind of thing, right? And that's where we see wow, we need to change paradigm. We need to have tools that are adapted to our new challenges. That's these exciting challenges. We need to be talking about these in a different manner, not in this kind of toy kind of manner, but rather in a serious manner. Now we want to be analyzing big sets of data. That's obvious. we need to be using different machines for doing this analysis. And also we need to be to integrate different sets of data coming from different places in different formats, right? With transformation, we need to start transforming data. And in the same time having a lot of user requests, because we're living on the internet, and internet has, suddenly we will be faced with these kind of issues, right? Completely different set of requirement and challenges than what we used to have before. And that's the exciting part about it. Like now we're doing problem solving. Now we're back to problem solving and data. Now I do what I did in the last 2 years. I was working in this framework, web framework that runs on the JVM called Playframework, and I got into the next city. And then I got the last releases of Play 1 framework. I did some the last release of that. I mean, I helped doing that. And also I started with Guillaume this Play 2 framework. It was Play 2. Why did we start this framework? It was exactly for these challenges that we were talking about. We wanted to handle these challenges for web apps, but really from scratch, thinking about the problem. Like, we got these problems. How can we solve these problems? Okay? How can we solve these different problems if we can start a web framework from scratch? Okay? So it's basically a Playframework runs. It's a framework that makes web development easy on top of the JVM for Java and Scala programming language. It's lightweight. It's stateless. It has its properties that makes it scalable, and this architecture makes it highly scalable, and it's well fit for real time. Something we will talk about later. And it has this reactive mode. Something not. I will not focus a lot about it, but it's a different kind of model where you're kind of notified and composing these notifications. We will talk a little bit more about that, but that's not the focus of the talk. And it was designed to be living in the cloud, integrating different services, and we will see more about this. Earl, can you do us just to have some understanding of what Play, how does it look like? Well, that would be hard actually that you hold the microphone. I can hold it.
Yell at the microphone.
Okay.
Okay, so I'm kind of the comic relief demo guy. Hopefully it's not too bad. But okay, I'm sure you're very excited to see another web framework demo. But I'm going to just show you the basics just to give us some context for what's coming in the next section. Okay, so if you don't care, just bear with me. So let's start at the beginning. Here's a part of the Playframework page. As Sadek said, we're looking at like the lightweight, stateless web framework. It has all the things you kind of expect in a web framework. It's super easy. It's super good if you're a web developer. It's excellent fun. It's a good fun framework. But like I said, we expect that from web applications. It's nothing special. But just to get you started, go, if anyone wants to try it too, head to the page, grab it. You get a zip file. Unzip it, get it in your class path, and then you will have access to the Play console. Let's see here. Once you're at the console, once you've got your console, then you can get this beautiful little helper here that tells you this is no Play application. So to start a new web app, we just go Play. Can anyone see that or not? Oh, yep.
Can you start like recording the screen, because I guess we will need that.
Nope.
QuickTime.
I'll do it later.
Well, it's very fast. I will do that. Just we need. Okay.
Oh.
Just a second. It will take a second.
See how easy it is.
Oh, why does this thing keep happening? File, new screen recording, and that's it.
All right. Okay, cool. Play new, and you give it the name for your next big social Instagram sharing flipper application to share your dog's pictures. And it will ask you some very difficult questions. What is the application name? We've already said this. What would you like to write it in? Scala or Java or nothing? And some iterate things. We want Scala, of course. And that's it. We've got our applications being created. It's created a structure for a simple for an MVC project. Play isn't MVC, like it's not baked in, it's built on top of Play, but it's very useful, so that's why I was saying.
So basically here you're not doing any decision that you're committing for the rest of your life. You're saying Scala because Play will just start generating some sample controllers for you to start from, but you can mix Java and Scala in the same framework. That's no problem. You can have some controllers in Java, some controllers in Scala, calling in between each other. There's absolutely no problem. Both work together. Now we're starting the app.
Downloading the internet. And it's running on port 9000. Screen recording things in the way. And when you run it,
you can minimize it.
Does some more thinking, does some compiling.
And that's interesting here, because you started the application, it didn't compile anything. And then when you hit the page, it starts compiling. And that's one of the interesting things in Play. We need you to have two focuses. One is a browser, where you're seeing the result, and one is what's behind your code, it's what you're coding. So each time you run the app, each time you modify your code, you go to the browser, you refresh, it will go compile your code and show any errors that you got on the browser.
And there's a few things it sets up. It sets up some routes and some basic. It's got a controller and welcome message. You can replace the welcome message with. We're passing a message through from the controller already, and get rid of the how you do everything page. Does a little bit more thinking. Sorry, I had to restart it. And your new application is ready, which is getting passed out of here. And one of the coolest things when you're developing is if you've made a mistake, and I've got my string unclosed here, and refresh, it says, oh no, you've unclosed literal on line 9. And you go, hey, I guess that's quite correct. Anyway, that's a quick overview of how this works. It's really fun to develop in, but I still think it's got everything you need in a web framework, but it's got more, and that's where we'll talk about today.
So basically, just to get the idea, that's how the thing works. It has some MVC kind of structure. It's very close to architecture, to web architecture. That's why we'll be talking about OK status. We're talking about not found on all these things. We'll be talking about it explicitly because we want to know what's going on behind. Now you got okay. So now why did we do this framework? Because it started with this kind of architecture where we had one machine. It's a single box thing, okay, where we have the web framework and the database both in the same machine. They talk to each other, and that's it. And the whole architecture was done for this kind of thing, for this kind of architecture. But now everything has changed, right? Now we have different servers, different data stores, different things we want to interact with, and a lot of connections. And we need to handle these kind of things. This is what we talked about with the cloud and distributed computation. We're talking about new era with new challenges. Now, we thought about okay, data. We need to handle a lot of data, and that's what functional programming is very good about. And that's why we went there and integrated Scala, the Scala programming language, the functional programming language that allows with functions and higher order functions, collections library. It allows you to do this manipulation of data very easily. But that's not the focus of the talk. But that's one of the aspects why we integrated the Scala programming language. We are sure that you need to be able to talk more easily about data, and that's what functional programming is good about. And you want, so the second that I will be mostly focusing on is using several machines for computing and analyzing data. And then you got also integrating different sets of data like parsers, APIs, and that's also what functional programming is good about. We got some parsers there. You can parse different formats. We provide our own transformers for JSON, for XML, and other types of data, but that's very easy. And we provide some transformers, but also as well, it's not the focus of this talk, and it's also about handling lots of users with a stateless reactive architecture. That's one thing that we do in Play. So now what we're focusing on is use distributed computing, which means I have something to do. I want to send it to several machines, and I want to aggregate this data back and push it to the client, right? This is what the web framework, what will it be doing, right? It will be starting these things and getting the results, pushing them back to the client. So the problem here is that you could do it. I mean, with different frameworks, you can do it in different ways. But we need a programming model. We want to do these kind of tasks much easier, right? We want to do like expressing this kind of composition of computation much easier. Now we thought about it, like how can you represent a computation? How can we talk about this kind of computation that's happening somewhere that eventually I'll get its result? Okay, so basically this is the idea. It's a computation for which eventually I will get a result. Okay, and how can I manipulate them? So we got in Scala, it was integrated recently, and we had actually our own implementation, but then we migrated to the Scala futures. We had this concept of future. Who knows what future is? Okay, so future actually is a structure that will be representing a value that's happening sometime in the future. Okay, just saying this. Now, how does it say that? Well, it has a kind of callback mechanism inside the future. You can say like, let me know when, well, execute this function whenever you have this value t, and it will be running your code that way. Okay, so basically that's it. It's a delayed. It's something that's happening sometime in the future. You get this representation. It can be a future of int, future of string, future of list of things, whatever it is, right? It's just an abstraction, something that represents something that is happening in the future. Okay, but that's not it. That's not all. So basically, future of t is t that is happening in the future. Scheduled on different machine, whatever it is. Now, a future is also has some so represent a value that will be available in the future, or maybe failure. Okay, the same thing. You will have both aspects of that, and provide a way to be notified whenever this happens. Okay, that we know about. Okay, some kind of callback mechanism, but that's not interesting. We don't want to be doing the callback things. That's not good programming, right? On callback and you get nested structures. We don't want. But that's inside the future. That's one possibility. That's the possibility that allows us to compose these. But just that's not how we'll be using them. What we've focused about when we're interested in is some composition properties that we got on these futures. So one interesting thing with futures is that a future of A is a future of A. And that's kind of obvious, right? If I get a future that will give me a future which will give me a value of type A, I could say like it's a future that gives me a value of type A, right? Obvious, no problem. But that's a very nice property to have actually, and we'll see why in a minute. Also, one other thing, if I get a list of a lot of futures that will be given values. Can I imagine it? Can't I imagine it like a future of giving list of values, right? So list getting inside the future. Instead of handling a lot of things happening in the future, I have only one thing that is happening in the future and give me all these results. And that's also an interesting property, right? And it's obvious, right? When you say like there are a lot of events happening in the future where there's one future and a lot of things happening in it. And also another property is that if I get a future of A, and I have some way of telling how to go from A to B, it means I can have a future of B, right? And that's the map function. And that's also an interesting property we get on these futures. And with these properties and some others, we can do very nice API that can help us talk about composing these computations that happen, that will be providing results in the future. Okay, these properties, and then we can have APIs such like map, flat map, filter. I get a future. I'm only interested in certain value. Otherwise, I want a failure. I can do that. I can collect some kind of thing. I can recover from errors and provide other kind of values, and so on and so on. I can say like I got two futures, and I want just the first that happens, the one that happens first, or the one that doesn't fail, and all these kind of things. And now I'm talking about a programming model, right? I'm talking about things in a declarative manner. I'm saying like I want to have the first that happens. I got 10 futures. I want the first that happens, the first that redeems or happens, and that's interesting to be able to express it that manner instead of doing all the concurrency or the synchronization locks or whatever you happen to do it. Well, you got it in the model, in the programming model, and that's also like already much easier to deal with. And now, like, we want to use these features when we distributing computation, right? We have this, we distribute computation, like we try to imagine these computations are as futures of things that will happen, the things that will happen in the future. I want to compose these and push them to the user, right? Very, very straightforward. Now we got this, the app that we were working on is something that is a tool that is, productivity tool that it's used for to read some financial data and provide a lot of visualization to help the user of that tool decide about some things. So it's rather exploring a lot of visualizations and saying like, oh, okay, this makes sense, or maybe this doesn't make sense at all, and then continue interacting with this thing. And what's important, since it's a productivity tool, you need to have it very fast. Actually, you're distributing your computations on a lot of machines, but you want them to aggregate that as soon as possible, as soon as they happen, and push them to the client. All right? So basically what we got here was with the browser, all right? So we got the browser with some kind of backend, is the web framework that we were dealing with, that will be calling two services. Okay, one service is a distributed computation that will be the first one that will be getting some data from a big data for specific context, and then it will be getting this data, and with this data it will be like calling the other service that will be drawing some graphs, giving back the graph, give it to the browser. Okay, simple scenario. I think two fantasy in there. Let's see how can do. Can you show us, Earl?
Again.
How can we do that?
Okay, so just a bit more context on the project, which we're not allowed to talk about. It's meant to be it's for financial services, so it's using a lot of financial data, and the charts that it's providing are based on big amounts of data. But the application itself is iPad, made to be consumed on an iPad in a sort of as a discovery tool. The dude's supposed to sit there, flip through this, it's like you make a hypothesis, and then using the parameters of this hypothesis, we're generating hundreds of charts so it can, that matches or confirms or denies this very quickly. The process happens already now. They're actually doing this, but it's slow and manual, and instead of computers, they have some overpaid guys who sit on PowerPoint. So it's a good scenario for this kind of thing. The way that I'm going to show it today is not in a super sexy iPad app. It's going to be in a simpler form. And just make sure we're still running this one. You can go away. I think this is it here. Thanks to the help of Twitter Bootstrap. This is kind of an example of some of the charts that we need to generate, and as Sadek showed you in the architecture diagram, we're getting data. The data is terabytes and terabytes of data we have to go through to query that and get it back. Takes time. When we get it back, then we have to send it off to our renderers. We've got a whole bunch of things sitting there rendering these charts. They have to do it quickly, otherwise it's not a useful tool. So things have to happen quickly and have to happen, as fast as we can. We need to scale it out. If we have more users, that's a lot more of the same stuff. It has to happen quickly. Okay, actually, I'll just chuck it in here. This is the super simplified version of it. At the moment, it's running off doing these calculations. And this is how it can work on the iPad now, in that this data might have been, there, it all just came back, and it's good. We've got a bunch of these categories, they all come back at different times. And the older data, if it's not the most current data, it'll be great and fade in with new data as it comes in like this. To do that with the futures, I'm just going to switch over to some code. Here's the service. Here's our big data. It's a list of ints, of tuple of ints of int of int. So it's very beautiful. It's our service. Here's our renderer service, which is calling some of our other our visualization API. And here's the main thing that we want to talk about right now. So, first of all, the process comes, the user's there, they're selecting a bunch of charts that they want rendered. And it's There'll be hundreds of charts, and we get these list of things that they want new versions of. This goes off to our data API, and we come back with a list of these futures of the data that we need to think. So we get a whole bunch of these lists of the futures. Once it all comes back, once that's redeemed, we then come into our chart. So send it off to our chart renderer. Okay, and this is also a list of futures. We end up back from here, but we've passed them through to our chart rendering service. Okay. Once we get these back, and they've all come back, we've got a list of futures. But as Sadek said before, with one of the properties of futures is what's more interesting to us is to transform them into a future of our data, like just one
list of data.
One list that we can then send back to our requesting our guy. It says, okay, we've got these charts, we've got the data, we've got the rendered, boom, you can display it. And this can be sent off to as many machines as we need to do it.
So basically, the interesting thing also as well that we're not showing here, but it's in the controller side, is that Play accepts a future of something, and it will be serving it whenever it happens to the user, right? So with Play, you can either return a plain result, which is like just OK, not found, whatever it happens, or an asynchronous result, which happens to be a future of a result. That will be what we cooked, what we just prepared in that API. And also the interesting thing is that we started with the first service. We sent a lot of requests. We got a list of futures. Now for each of the futures now, we request another service that itself will be returning a future. Now for each of these futures that we got now a future of something, right? The first is the future. Inside the future, I say, okay, for the value inside the future, I'm going to get the chart URL, and it gets me a future. Now I get a future of future. But since we have these properties with a future, that future of future is a future. So a future of a URL is a future of a URL. Now I got just a list of futures of URL, which is fine. And now with the sequence method or function, I can turn that into a future of list of values that I can go send back to the browser. And that's exactly what happens when we go. Can you show again the example of the, yeah, so that's exactly what happens when you enter here. Now all these that are happening, they're being computed, and whenever everything is done, every single chart here is done, then the result will be pushed back to the client, and the client will be showing it. Okay? The request might last for longer, but that's not a problem, because Play doesn't block any resources while the future is happening, and that's one good part of good property of the Play framework. All right.
And we can send off a bunch of requests to get back chunks that are relative to where they're looking at the moment. Back to you.
So that's kind of nice. We could do this kind of thing, represent each computation as a future. Or represent each thing as a future, and then wait for all of them and send them back to the thing. But the good thing in the future API, there are a lot of other interesting functions. As I said, you can say wait any. For instance, you can select a lot of futures, and whenever you got 10 of them, you say okay, that's good for me, that's enough. Or I'm waiting for the first response that happens to have the result, or whatever other kind of things you can compose. You can even compose some kind of workflows where you say, okay, I'm starting these 10 things, and whenever they have results, I'm starting the other computations, and so on until you get back your results. This API, this programming model of composition of futures, allows you to do that in a very simple manner. All right? We move on. Now, we just said about our context is that what we focus on is productivity and discovery, right? We be able to discover things and discover these visualizations as they happen, so that the user can take some decisions, can even completely change what he's doing, and if he discovers some visualizations that don't fit his theory, right? He starts this is my theory, I get some graphs, that's not the right idea, let me change it. But what we do in here, and that might be a perfect fit for a lot of contexts, but for our context here, we're not showing any graph until every single graph is rendered, which is not really cool. Because some graphs happen right away, some happen afterwards, and if I can start pushing these things to the user as they happen, maybe the user will have the decision much before the last one is happening, right? Maybe, and also it's annoying to see an interface that is waiting for so long. Just nothing happens, and then boom, everything's happening. And we got the opportunity here because these machines, they're independent. Maybe some machine is loaded, the other is not loaded. Whatever it happens to be the context, we will be having things in different speeds. So what we need to do actually in here is start streaming the results to the client whenever they happen, right? We don't wait for all to happen. We just, whenever something happens, we push it to the client, okay? Now, to be able to do that, we need several things. The first thing, we need to have a protocol with a browser where we can send things in a kind of chunked way, not one response, but I will be pushing several messages. And that's, I need to be able to talk with the browser that way, okay? That's the first thing. And also, at the server side, I want to be able to talk about streams of data, right? Not a future, not something happening in the future, but a lot of things that are happening in the future. It's a stream of data, right? And how can we transform this list of computations, list of futures, into a stream, right? Because these things are happening concurrently. Any of them can happen at any time. How can they push all of these in one stream that is pushing messages whenever they happen? These are the questions that I need to answer in my architecture, right? Now, how can I do that? Well, first thing, on the browser happens to have this, especially new browsers, they have the technology necessary for having this kind of communication. We start with Comet, which is some kind of hack on top of HTTP 1.1, passing by server set event, which is a proper protocol for a server to client kind of communication. It's a very simple protocol. We can push messages into any browser. Especially, I mean, we're talking here about modern browsers, including Chrome, Firefox, Safari, and even IE. So, and we got also WebSockets. Now, WebSockets is kind of a problem of its own. There are proxies and all of these things, but I can, server sent events will work with any kind of proxy, so I don't have to worry about that. Okay, so we got the protocol to talk with the browser, with which we can talk with the browser. Now, what I need is at the server side a way to talk about streams, with which I can talk about streams. Now, whenever I talk about this, and we see all modern frameworks out there, like we talk about real time and all of these things, you'll see them doing something like this, like out.write message. Now, is it a proper way of talking about streams? We're not talking about streams. We're talking about the method where whenever you call it and give it a message, it does an effect that is sending something into a socket. Now, I don't guess this is the way we should be talking about streams. We need to have this kind of compositional, interesting API, the same that we have with lists, the same we had with the future. We need to have something like that. We need a programming model with nice properties, and it should be compositional. All right? Now, in Java, in the Java world, on the JVM, we got this input-output stream. Well, input-output stream, they're kind of nice. They can so provide an abstraction in top of something like getting in and getting out, which is kind of nice, right? The only problem they got two problems. First, they lack any composition functions or properties. Okay, they're good. They went the right path, but they don't have these composition properties. And also they are blocking, which is not good for our case. We don't want to block any resources if someone is trying to consume a message that is not there yet. Okay? So we need to have also non-blocking properties. So that was designed 15 or more years ago. And now today we're coming with these new things where we say we should out.write. So it seems like we're moving backward with technology. Now let's see. In Play, we integrate this concept that's called iteratee. That comes from the Haskell word that Sun decided to be strong. So we got iteratees in Play. Now, who knows what iteratees are? Who heard already of iteratees? Okay, a few more. So an iteratee is kind of, we often call it a fancy fold. basically, it's very, very simple. It's a kind of an immutable state machine. Okay? So iteratee has one of three states. Okay? Something that has one of three states, done, continue, or error. Okay? And whenever it has the continue state, you can give it some input, and it will give you back a new state of that, of iteratee. Okay? So basically, it has a state, we can see what state it has, and whenever if it has continue, I can give it even more chunks. That's basically the iteratee. So the way I read this is an iteratee is something that will consume chunks of type E, whatever E happens to be, and eventually, whenever it's done consuming chunks, it will return me something of type R. Okay? So iteratee is something that will be computing an R out of chunks of type E that passed into it. Okay? As simple as that. And it's very similar to the fold function we got in most of the functional programming languages, except that it has this property of being like progressive. You can stop giving it input, give more input, stop again, pause, do a lot of interesting things because of this structure that is kind of inside out. Okay, so we said like it's an immutable state machine. It got a done. Done will give you a result and whatever left of chunks that it didn't consume. And that's interesting for composition. Continue with a function where you can push more input and give you a new state of iteratee and error. Okay? Now, an iteratee has also nice properties. We can, if we have an iteratee of something, well, just it's an iteratee of something, right? We can imagine it that way, and that works, right? This is a nice property that it has. And also, it's well integrated with this future concept, because if I have a future of some iteratee, well, okay, I can have an iteratee, because anyway, eventually it will give me a result. If there is a future on top of that, I can flatten it inside it, and I can get an iteratee. And that's also interesting when we're dealing with computations. Okay, and also I got this map function where I got the iteratee of ER and a function from R to U. Then I can get the iteratee of EU. Okay. Nothing fancy here, the same kind of property. They look very much like the properties we got with the futures, right? Okay, so that iteratee represents the consuming part of the stream. It's the sink, it's where input will go, right? So it might be then computing something by the end, but it will be consuming input. Input will be pushed into iteratee, all right? Now, all the scenario I was talking about, where someone will be looking at state, deciding what to do about it, I was playing the enumerator role. So enumerator is just something that will take an iteratee with certain state and will return an iteratee with another state after pushing maybe some input into it, right? So basically enumerator, what will it be doing is saying, okay, what state you got the iteratee? It will tell, I'm in the continue. Okay, here's some chunks. Now, what state you got? Tell something else, and so on and so on. Either the enumerator will have no more chunks to push, or the iteratee will say, I'm done. And then that's over, and we get an iteratee with a new state. Okay? Very simple. Enumerator. Now, enumerator as well has some nice properties. Well, enumerator of E basically means I'm going to enumerate chunks of type E. Okay, whatever A happens to be strings, ints, JSON, whatever it is. Okay, and the nice properties on top of enumerator is kind of the same properties, right? Enumerator of E, so something is capable of enumerating an enumerator of E. Well, it's just enumerating E's, right? We can flatten out this kind of structure easily, right? And if we say like a future of enumerator, well, we can say it's an enumerator because anyway, eventually it will be given the iteratee, so I can flatten that out as well. And some functions like map for transforming input, flat map, interleave, I can get like a list of enumerators and concurrently interleave these to push in the same iteratee. And that's interesting. If you get like a lot of different streams coming from different places, like I said, I give you one enumerator that is representing all these enumerators, but in an interleaved concurrent way. And that's kind of, that's one of the very interesting properties of enumerators. And you can compose two enumerators like in this happens first, this happens after, and you can get this kind of, there are much more methods that you got in enumerators, but just I put just a few. Now, getting back to our application. Now, the problem here we said is that we're talking, so the browser is opening. It wants all these charts to be rendered. What we want actually is whenever any chart is, we got the data and we rendered it, is to push it directly to the browser, okay? And we will do that using the socket, the server sent event thing that we got between the browser. Can you show me the demo?
So I'm sure you're excited now. I'm going to go straight to the end result because...
How can you provide maybe the code first?
No, because I'm sure you've guessed, I mean, the end result, so we'll go straight there. But it's, as things are returning, we can display them directly in the browser, and it can happen whenever things are coming back from the data service, then coming back from the graph service, and then bang, it's on the page. And this is one of these great properties of what Sadek's just been talking about in using iteratees to be able to combine and
even the whole user experience here, if you look at this thing, the whole user experience is much different because I'm starting to have some input, and with some visual tricks, the user will not even know that things are happening. I mean, will not even notice that there is any latency because there are all, like always, results happening to the browser, and they can even make decisions before all the charts are loaded, right? Because there are hundreds of them. Maybe you will see something and you say, like, no, it was a wrong decision. I stop here and I start another kind of visualization. And that's the interesting part of it. We could address that problem at the interface because we got in the back end what allows us to be able to do this kind of very real-time kind of composition and streams.
Okay, I think we're nearly run out of time.
Are we?
But
what?
So I'm going to just quickly go through and say
2 minutes. And when does it end, actually? It's supposed
before. So the cool thing about the programming model that's provided to us is that the code to do the second part, which is our streaming aspects, are very similar. We don't have to change a lot to get these cool properties. In fact, we're still going to the chart service. We're still going to the data service, render service, and we're still getting back these list of futures. But we can then, because of what how Sadek was saying, we can convert that to.
So each chunk we got a future of A, right? Okay, a future of A is a future of enumerator of only one value that is A. But we said future of enumerator is an enumerator, which means I got an enumerator of A that is giving me a single value of A, which means I got a list of enumerators of A. Wow, that's good, that's interesting. I got a lot of enumerators that each of them will be enumerating only one value whenever it happens, the A that it has. Now, a list of enumerators, we can interleave them and get only one enumerator. That will be our stream that will be pushed into the user.
So that's pretty cool. Just get everything, smash it all together, bang, we've got this stream. We can just push, thanks to the client-side technology, we can just push them straight to we're using server sent events because it's just a one-way thing, pushes it out. It's very cool. It lets us, this is just one tiny example. There's so many things that you can use this for. It's so cool when you start thinking in streams and start thinking about how you can compose, how you can transform things on the fly, smash things together. This was just one. We also did the, I don't know if this will work if I have internet here.
The type-safe console?
Type-safe console, which is for monitoring the Akka applications, or it's not going to fit in my screen here. But this is pulling stuff from the Akka monitoring APIs as it comes out of the Mongo database, and it's really cool because it's getting a lot of data, it's pushing it as things change, and it's also got a cool property that if there's other people viewing pages at the same time, then we can broadcast these streams out over to as many people who are connected at the time without having to do separate requests. So anybody listening to this stream, whoever wants to listen to the stream can listen to the stream. We can pull and push stuff in.
And also one interesting of this thing is that we can compose these streams in a very, very, very easy manner, because we can get streams of nodes, streams of actors, and then the URL, you'll be describing whatever you want, and we will be composing in the interface. And that's exactly what the URL is saying here. I'm saying, like, on the left, I want all nodes, on the right, I want all dispatchers. And that's inside node 1. And that's, we get some streams, we compose them on demand, and we push them to the user. And that's not only big data, that's infinite data. That data is a never end, a stream of data. So we need to, like, the whole idea of the talk is to say, like, not only we want to distribute computation, we want to distribute computation in real time to provide functionalities like these that are not possible without this kind of interaction between the machines that we got, the server, and the client. And we need to provide this kind of easy integration with these kind of parties. Well, that's all. I guess we could fit in a talk. There are a lot of samples come with Play. You can play with them. You can see there are examples also over the web of services that use this kind of technology. So it doesn't replace distributed stream processing, but it's rather for integrating these into a web app and pushing it into the client.
Easily and funnily.
Okay, well, that's it.
Thank you.
Well, thank you for...